homework time. Here we go with homework time. Happy homework time again. Lesson 11, working on some multiplication. Well, let's start by jotting our names at the tops of our papers. I'll put my name and you put yours. And while we're here, let's take a quick moment to put down today's date. I will write today, and you write the actual date, where and when you are. Our instructions for this first page are as following. Solve the following expressions using the standard algorithm. That's that usual way of figuring things out. That's what the standard algorithm means, and for multiplication. The partial products method, where you have like a ones place product, a tens place product, a hundreds place product, and you combine them. And then the area model, which of course is this little picture here. So let's do all three for these so we know how to do everything. Okay, so what do you say? Let's go with the area model first on this one, okay? So what we have here is we're looking at this rectangle, and again I'm going to have to make some assumptions. You know your multiplication facts, and that you basically have some grasp of this lesson, what the area model means, and you're just looking for how to get this done. So this side we will call the 8 in our 8 times 302. And then we're going to bust out the 302 by place value. You see this larger section we'll call 300. And then this smaller section we'll call 2. And notice that even in happy Eureka world, these things are not drawn to exact proportions and scale that, you know, the 2 would be a tiny sliver, but, you know, we just kind of give it a shape so we can say, hey, that's what it is. And so what we're doing here is we'll first multiply, see, 8 times 300 plus 2. We're decomposing or using a distributive property here to break it down into steps. So we can do 8 times 300 first, and then add to that the product of 8 times 2. So what is 8 times 300? Well, we'll break it down further into 8 times 3 times 100. 8 times 3 is 24. 24 hundreds, right? 2400 or 2,400. And so we're actually calculating the area of this section of the overall rectangle. And then over here, we are doing 8 times 2, which is simply, 16. Yeah, there you go. All right. Yeah, that's it. I mean, we can go ahead and I'm going to write out the whole product there. That would make sense. They don't ask us to, but we'll do it anyway. 2,416. Pretty easy addition there. And I wanted to do that one first because that'll help us to see what we're doing in the other two methods. In fact, I want to continue working backwards. And here in the middle, I'll do partial products with you. So we're saying 302 times ye old 8. And you'll see that partial products perfectly mirrors what we just did in the area model. So 8 times 2 we know is 16. And note that I am lining up my place values. Important. The 8 times 0 we can just omit because we would just have 0 written here, and we know that's not going to change anything. We didn't have anything we're regrouping or anything to deal with there. So we'll move on to 8 times 300. Do not say 8 times 3, my little friends, or you'll end up with 40 as your answer and say, scritch, that doesn't make sense. So it is 8 times 300, just as we did, in that area model. So we already know what that product is. It's 2,400. And again, lining up those place values. Add these together, and yes, just as I did over there, I will again get 2,416 as my product. Lovely. So now that will make the standard algorithm even easier to do. Again, we're going to write 302 times 8, but we'll do one thing slightly differently. We'll regroup instead of writing out separate partial products. So remember, when we're doing standard algorithm, we can just look at it as 8 times 2, 8 times 0, 8 times 3, and we don't have to be as concerned with place value, although we still have to line them up right. Watch, you'll see. 8 times 2 we already know, we just did it twice, is 16. Now in this case though, instead of writing out the full 16, I place the 6 and regroup the 1 in the tens place here. So when I do 8 times 0 is 0, I then say plus 1, crossing it out, so I remember, okay, I used that. So 0 plus 1, of course, is 1. And then 8 times 3, we know, is 24. Lovely. And of course, we then, for a third time, get our 2,416. Great, that's 1A. We know how to do these. We'll move a little bit more quickly through the next few. Let's go. And here on 1B, we have more of the same, but we have to do a bit more of the work. So let's go again in the reverse order that they gave to us and start with the area model, okay? So we're doing 216 times 5. And so the shorter side of our area model here, we will label 5. And then the 216 will break out, we can say into expanded form. You see why we did that as 210 and 6. Common mistake there would be to say 216 because 16 is one word and yet it's two separate place values for us, all right? And so simply here in the parentheses I'm doing the same thing. I'm expanding 216 as 200 plus 10 plus 6, which tells me I'll be first doing 5 times 200, adding that product to the product of 5 times 10, and adding in the product of 5 times 6. Lovely. And now I can actually go ahead and do that multiplication. So 5 times 200, break it into 5 times 2 times 100. 5 times 2 is 10, times 100 is 10 hundredths. This is an easy one to make mistakes on and end up with either 100 or 1,000, 10,000, whatever. And maybe you're right, maybe you're wrong, who knows? So the way to know is to say 5 times 2 times 100. 5 times 2 is 10, 10 hundreds, 10 hundreds, 100, 200, it's 1,000, yes. 1,000 is the correct one. And then here, nice and easy, 5 times 10, we know is 50, yes indeed, and 5 times 6, yeah, 30. And you can probably add those in your head because you see 50 and 30 make 80, and 80 with 1,000 is, right? Then we're going to give us a place to put it, but I want to write down, it's not really in order, but I do want to write down my final product here, which is 1,080. Great. And now let's go ahead and do it in partial products, which really echoes the area model we just did. So 216 times 5. And lining up place value is important. Paying attention to place value is important with partial products here. So we'll first do the 5 times 6. 6 is in the ones place. Its value is 6. 5 times 6 is 30. Lining up my place values for better addition. Now 5 times, did you say 1? It's 10, isn't it? It's a 1 in the tens place. Its value is 10. 5 times 10, just as we did over here, we already know is 50. And don't say 5 times 2 because it's in the hundreds place. It's 5 times 200, which we just did as well. So we already know it is 1,000. Again, lining up those place values. Let's go ahead and add them up. And we already know what we're going to get, 0, 8, 0. But actually do the addition, because if you get something different, don't just write it down. Because you might have messed something up. Who knows? It can happen to all of us. 1,080 again. And now let's do it in the standard algorithm. And if you haven't figured this out yet, let me just make it clear. Our goal is the standard algorithm, that you will not be doing partial products, you will not be drawing area models or using the distributive property to perform multiplication in the future, that you will be using the standard algorithm. But these are the building blocks so you understand what you're doing when you multiply instead of just blindly following steps. Okay, with that said, let's go ahead and do our fancy friend, the standard algorithm. So now we're just talking about 5 times 6, 5 times 1, 5 times 2. All right, because we'll put it in the right place value, so it has the proper value. All right, so now 5 times 6, yes, is 30. we place the 0, regroup the 3 in the tens place. It's below that 1 there. 5 times 1 is 5. Cross it out with me. Plus 3 is 8. 5 times 2, we know, is 10. Place my comma, and look, bing, bing, bing. Got the same thing 3 times. Let's go on to 1C. All right, now in 1C, we have more of the same, but they're giving us a little bit less to go on. We have to figure more things out ourselves. So we're looking at 593 times 9. Fret not, dear ones. Here we are. So we know this short side of the rectangle would be our 9, and that the 593 we will put into expanded form as 593 as such. And so that's what we're doing here, is what we just did above, is we're saying, hey, what we're thinking of this is 9 times 500, rather, 9 times 500 plus 90 plus 3. No prob, Bob. And so then we will use the distributive property and say, okay, well, we can think of that as 3 separate products that will combine, which would be namely 9 times 500, adding that to 9 times 90, combining that, adding it to 9 times 3. And now let's actually do that multiplication. So 9 times 500, well, we simply do the 9 times 5 times 100. 9 times 5, 45, times 100, 4,500. 4,500s. 4,500 is 4,500 in standard form. You see why we spent a lot of time on expanded form and standard form? Look at this madness, we're using it. So 9 times 90, again, 9 times 9 times 10. 9 times 9 is 81 times 10. We know all this from place value. Yes, 810 then. And then we'll do lastly 9 times 3. Yes, you know your facts, that's 27. Now to add these up, we could try doing this in our head, but I think it's a little bit safer to combine them over here. Let's actually do the column addition. 4,500, adding to that 810, adding to that 27. There we go. 0, 0, and 7 are 7. 0, 1, and 2, yeah, 3. 8 and 5, 13. Regroup that 1. 1 and 4 make 5. Place the comma. 5,337 is what we get. Now when we do partial products, we're doing the same thing. 9 times 500, 9 times 90, 9 times 3. So let's go ahead and do that. So we'll write it out as 593 times 9, paying close attention to place value in partial products where it really matters. Well, I guess it always matters, but especially here. So 9 times 3, we just did, we know it's 27. And 9 times, did you say 9? It's 90, right? We're paying attention to place value here. 9 times 90, we also just did, we know it's 810. And then 9 times, not 5, but 500, yes, is 4,500. 4,500. The bells! What are you going to do? It's a skull. All right. And even though we did just add this, let's check our addition by kind of blinding ourselves to what we just did and make sure we actually really get the same answer instead of just copying it. Because if we made a mistake before, we wouldn't catch it now. So 7, 0, and 0 are 7. 2 and 1 make 3. 8 and 5 are 13. Regrouping that 1. 1 and 4 make 5. And yes, indeed, we still got 5,337. Which is going to make it so much easier now for us to do it with the standard algorithm. 593 times our good friend Mr. 9. There we go. So 9 times 3 is 27. We place that 7 and regroup the 2 in the tens place. 9 times 9 we know is 81. Cross out with me. Plus 2 is 83. Regroup that 8. Now, we have a little bit of mind contortion to do here. 9 times 5, we know is 45, plus 8. I'll tell you what actually goes on in my head when I do something like this. 45 plus 8. I think of the 8. I say, I can make 10 with, if I think of 8 as 5 and 3. So 45 and 5 is 50, and 3 is 53. That's really what goes on in my head. It can be a scary place in there. So again, 45 plus 8 is 53. And we place our common, 5,337. Bing, bing, bing. We got 3 times. We are rolling on to number 2. Well, despair not, my beloved ones. I know you're thinking, oh, we just did all that work and we're only on number 2 and there's 6. You're flipping forward. Oh, there's... These will go quickly. Trust me, it's easy. Because all we have to do now is just see, look, partial products method. So let's read and answer this. No problem. On Monday, 475 people visited the museum. On Saturday, there were 4 times as many visitors as there were on Monday. So how many people visited the museum on Saturday? We can probably skip, I think, drawing a tape diagram here, because we'd say Monday's 475, Saturday's 4 times as many. We got this. All right, so let's do partial products of 475, and there's 4 times as many on Saturday. So that's how we know we're multiplying. You won't always know. You'll have to figure it out, all right? So with partial products, we'll say, remember, we have to pay attention to place value here, okay? So we're not doing just 4 times 5, 4 times 7, 4 times 4. We're going to say 4 times 5, 4 times 70, and 4 times 400. So let's think that out before we do it. So 4 times 5, of course, is 20. Lining up our place values. 4 times 70 is 4 times 7 times 10. 28 times 10, 280, 280. Very nice. And then lastly, 4 times, 400, right? 4 times 4 times 100. 4 times 4 is 16, times 100 is 1600s. 1600 is 1,600 in standard form. And we just combine these 3 partial products. See how fast this is going? I told you. All right, 0, 0, 0 is 0. 8 and 2, of course, we know make 10. We will agree that 1. 1, 2, and 6. 9. Very good. And 1 is 1. Our answer is 1,900. Does that make sense? Yeah, it's about 500 times 4, which would be 2,000. This is close to 2,000. It makes sense. So we want to say on Saturday, comma, 1,900 people. We don't know how many pets came along, how many people were counted, visited the unnamed museum. Got it. See, I told you it would be quick. 2 is done. Let's go on to number 3. Move it. And number 3, we will draw a tape diagram, but then we'll just solve. It says, model with the tape diagram and solve. And what are we solving? 6 times as much as 384. Okay, this is exactly the kind of thing you're going to see on tests, right? Or maybe as a part of a word problem. You know, there were 6 times as many on, blah, blah, blah. All right, so let's model with the tape diagram. So we'll make it, so here's 384, right? Sound good? All right. And then I'll draw a second one, a third one, a fourth one, a fifth one, and a sixth one. And I can call this whole shebang here 6 times as much as 384. All right. Good enough? All right, so, and solving, we just did partial products, so let's do standard algorithm on this one. So 384, and we're doing times 6. Remember now with standard algorithm, we're just doing 6 times 4, 6 times 8, 6 times 3. With the regrouping, it's putting it in the proper place that adheres to the correct value instead of the way we have to pay attention to place value in partial products. All right, so 6 times 4 we know is 24. Very good. And place that 4, regroup the 2 in the tens place. 6 times 8. Yeah, one of my favorites. 48. Cross it out with me. 48 plus 2 is 50 indeed. Place the 0, regroup the 5 in the hundreds place. 6 times 3, 18. Cross it out with me. Add 5. 18 plus 5. Got it? 23. Good. And does that make sense? It's about 400 times 6 would be 2400s. This is 2300s and change. Okay, that makes sense. And we don't need a statement because solve was our instruction. So there we go. Done. I told you it was going to go quickly. Nothing to worry about. Let's roll over to number 4. Hey, don't freak out on me. I will point out one word in these instructions. It's very important, which is the word or. Okay, so it's giving us a choice of which method to use to solve here. So we can solve using the standard algorithm, the area model, the distributive property, or the partial products method. It's our choice. We don't have to do all 4 like we did back on number 1. Since the standard algorithm is ultimately our goal, that's what I'm going to go with on this one. If you want to do one of the others, go ahead. Don't let me stop you. So 6,253, and we are multiplying that by 3. And remember with standard algorithm, it's where we place our products that recognizes their value. And so we just think of it as 3 times 3, 3 times 5, 3 times 2, 3 times 6. All right, so let's do exactly that. So let's start off with 3 times 3 is 9, yes. And 3 times 5 we know is 15. I will place the 5 and regroup the 1 now in the hundreds place. 3 times 2 is 6. Cross it out with me. 6 plus 1 is 7. And lastly, 3 times 6 is 18. Beautiful. See why I went with this? Boy, is that much easier, huh? So 18,759. Does that make sense? Yeah, we're doing about 6,000 times 3, which would be about 18,000. Makes sense. Look how quick that was. We should probably just kill some time now. All right, number 5. And in number 5, yes, same old dealio. Here we go. And there's a 0 in this number, so we have to pay attention to that, but it's not tricky or anything. So I'm going to go with standard algorithm because ultimately that's our goal here. We're doing 7 times as many as 3,073. It's customary and useful to write the larger number on top vertically and make sure we place the 7 in the ones place for that factor. And remember, in standard algorithm, we're just looking at 7 times 3, 7 times 7, 7 times 0, 7 times 3. Okay, so let's do that. 7 times 3 we know is 21. We will place that 1 and regroup the 2 in the tens place. And so 7 times 7, yeah, 49 plus 2, 51, okay, plus 2, sorry I didn't cross it out, 51, and we regroup that 5 in the hundreds place. 7 times, now just be a little careful when you see zeros, generally, in math. 7 times 0 is 0. 0 plus 5, crossing it out, is 5 indeed. And then lastly, 7 times 3 is, well, we just did it, yep, 21. Place the comma, we get 21,511, which makes sense because this is about 3,000 times 7 would be 21,000. 21,000. Hey, I told you these last ones were going to go quickly. Look, we're already going on to the last example, number 6. And in number 6, the topic is rice. Yeah, that's right, rice. We do have the familiarity of the cafeteria, though, which makes 2,516 pounds of white rice and 608 pounds of brown rice every month. Nice job, cafeteria. After 6 months, how many pounds of rice, meaning both white and brown together, does the cafeteria make? Okay, so we could see we need to put these together, right? In fact, if we were to draw, here we can draw like a kind of a cute little area model. What we're doing is we're saying, hey, we're doing 6 months, and this would be 2,516 plus the 608, and that would give us our total for 6 months, right? So we could start off by adding together the 2,516 pounds of white rice. That just strikes me as a lot of rice, even for a month. Yeah. All right, anyway. And then 608 pounds of brown rice. I prefer the brown rice myself. I know what you're thinking. Ew, nasty. I know. I like it. All right, so we're adding here just to get our 1 month total of rice. So then we can then multiply that by 6 to get a 6 month total of white and brown rice together. All right, so 6 and 8 together plus make 14. Good. Regroup the 1. 1, 1, and 0 are 2. 5 and 6 make 11. Regroup the 1. 1 and 2 are 3. So that's white and brown together for 1 month. And so now if we take that 1 month total, 3,124, and multiply it across 6 months, we will have our 6 month rice totale. And a quick estimate, you can even just glance at and say, oh, 6 times 3,000, 18,000 we should be about, okay? And let's, of course, go with standard algorithm because that is ultimately the goal here. So we'll just be doing 6 times 4, 6 times 2, 6 times 1, 6 times 3. Let's hit it. 6 times 4, yes, 24. And we regroup the 2 in the tens place. 6 times 2, 12. Cross it out with me. 12 plus 2 is 14. Regroup the 1 in the hundreds place. 6 times 1 is 6. Cross it out with me. 6 plus 1 is 7. 6 times 3, yeah, exactly what we expected to find there is 18,744. Now this is a word problem, so we do need a statement. The cafeteria, bless their hearts. Oh, bless their rice-loving hearts. The cafeteria, that was a tribute right there saying cafeteria. The cafeteria makes, there's a lot of rice, man. 18,744, and the abbreviation for pounds, I'll show you, is, you can write it as LB or LBS. Personally, I prefer LBS. And where that comes from, I'll tell you. The Latin root libra means weight, or is that a Greek root? No, the root word libra means weight. That's why the astrological sign for Libra is holding scales. So to weigh something is Libra, and that's where we get the LB for pounds. See, so if you've ever wondered why is pounds, which starts with a P, you would think PD would be pounds, but no, it's LB from Libra. The cafeteria makes 18,744 pounds of rice, and we do need to specify here, in 6 months. Excellent. Wow. Well, look, you've gone and done it again. This homework time is complete. Excellent job. I will see you next time. It is once again homework time.